Assalamu alaikum. Greetings to you from wherever you are watching this video. So in our previous video we discussed exercise 4. So in today's video we are going to solve exercise 5 problems. So in exercise 5 we have two numbers. Number 1, we are simplifying complex numbers from A to F. Then in number 2 we are verifying, we are proving the complex numbers from A there to D. So as we are going to solve these numbers, so you need to be having paper or exercise aside, so that you will also be writing together with the main. Okay, we need to start with A, the first one, the first complex number from number 1. Number 1, A is saying that 4 plus 3i times 2 minus I. So here you are multiplying two complex numbers, this complex number and this one here. So in normal multiplication of complex numbers, so what you do, you first take the first term of the first complex number, then you multiply it times second complex number. Here we will multiply 4 times 2, 4 times 2 minus I. Then we take the second term, which is positive 3, positive 3i times 2 minus I. So in this step here, what you have to do is to open the brackets by multiplying those numbers outside the brackets. So 4 times 2 here will give you 8. You will have 8. 4 times negative I, it will give you negative 4i. 3i times 2, you will get positive 6i. 3i times negative I, negative and positive will give you negative 3 times the coefficient of I, which is 1, is going to be 3. I times I, it will give you I square, you see. So what you have to do here, you need to substitute I square with a negative 1. Then you multiply negative 1 times negative 3. And as you do that one, this one is going to be real part, which is going to be the like term of 8. Here you will have 8 plus 3, because negative 3 times negative 1 is equal to positive 3. Then minus 4i plus 6i. In this way, you will now add the 2 here, which will give you 11. 8 plus 3 is 11. Negative 4i plus 6i. This will tend to be 6 minus 4, which is going to give you positive 2i. So this is the solution for the first question for number 1. I think it is understandable, so just follow the steps. Okay, let us come to the second number, which is this. So when you look at this one here, you are dividing two complex numbers. 1 plus 2i divided by 3 minus 4i. So in this division of complex numbers, we earlier understand that what we have to do, we multiply that complex number, both in numerator and denominator, by the conjugate of denominator here. What is the conjugate of this complex number? This complex number is 3 minus 4i. So its conjugate is going to be 3 plus 4i. So by changing the sign of the imaginary. So here we have to multiply the numerator, this one here, by the conjugate, which is 3 plus 4i. Then we multiply the denominator by its conjugate, which is 3 plus 4i. Here we'll now multiply this complex number by this. Just do it the way we did this one before. So we will multiply 1 times these terms, or the real part and imaginary part. 1 times 3, you will get 3. 1 times 4 is positive 4i. Then you will take 2i and multiply times this one. Here you will multiply 2i by 3 to give you positive 6i. You will have positive 6i. 2i times 4i, you will get positive 8i square. Positive 8i square divided by 3 times this complex number. All will start with 3 times 3, which is 9. Then 3 times 4i, you will get 12i. Negative 4i times 3, you will get negative 12i. Negative 4i times positive 4i, you will get negative 16. Negative 16 is square. Negative 16 is square. So what do you do next? Substitute negative 1 in this numbers with the I square. Then now you multiply negative 1 times their coefficients. Okay, what we are going to do here, we will add this one. We will collect this one as like terms because they are real. So 3 plus, because this one is positive 8 times negative 1, it is going to be negative here. It is going to be negative 8 plus 4i plus 6i divided by divided by 9 here. Okay, this 12 will cancel. 12i minus 12i, it will be 0. So in denominator here you are going to have 9 plus 16 plus 16. Negative 16 times negative 1, they will give you positive 16. So what do you do next? You have to work this one out. 3 minus 8. 3 minus 8, what will you get? You will get negative 5. You will get negative 5 there. Negative 5. Then positive 4i plus 6i will give you positive 10. You will have positive 10i here. Divided by 9 plus 16. It will give you 25. So this is the answer for number 2. That is the answer for number 2. Negative 5 plus 10i divided by 25. And that is all. Okay, for number 3, C of number 1, you are multiplying the imaginary part times the complex number. So here you will multiply this 7, that is 7i, that is outside, times all the terms inside here, and that will give you the simplest form of the complex number. Okay, let us do it. 7i minus 5 times negative 5 plus 2i. Here we'll multiply 7i times 5 times negative 5. So 7 times 5 is 35. But you know, this one here is positive and this one is negative. So it is going to give you negative here. Negative 35i. Negative 35i. Okay. Now you again multiply negative 7i times 2i. 7 times 2 will give you 14. Then I times I, you will get I square. Here you will have your opportunity of substituting I square with a negative 1. Then you will multiply this negative 1 by 14, and this will later give you negative 35 I minus 14. So you can bring the real number first. Negative 14 minus 35 I. So this is the answer for C. Okay, let us go to D, where we are multiplying two complex numbers. Here we have 1 minus 5I times negative 9. Negative 9 plus 2I. So in this one here, you will try this first term, 1 outside bracket, negative 9 plus 2I. Then you take negative 5 here, negative 5I times negative 9 plus 2I. And then now this one all will be negative 9 plus 2I. Negative 5I times negative 9. Negative 5 times negative 9 will give you 45, which is positive, because negative times negative will give you positive. Then negative 5 times 2, you will get negative 10, and I times I is I squared, so negative 10I squared. Then replace I squared with the negative 1, and this will result to give you 9, negative 9. Since this one is negative, this is going to be plus. So you will have positive 10 here. Positive 10, then plus 2I plus 45, 45I. So this is 45I. Negative 9 plus 10 is 1. Is 1. Then 2I plus 45I is equal to 47. 47I. So this is the solution for number 1D. Let us go to E. In E here we are multiplying 1 minus 8I times 1 plus 8I. So since we have already known the steps here, so let just say 1 times 1, it will give you 1. 1 times 8I, you will get positive 8I. Then take this one with its sign negative. Negative 8I times 1, you will get negative 8I. Negative 8I times positive 8I, you will get negative 64I squared. Then substitute negative 1 in place of I squared. Here you will have these two cancel together. Then what will remain here is 1. This negative and negative will give you positive 64. Here you will have positive 64. 1 plus 64 is the same as 65. Is equal to 65. So this is all for A, number 1A. Okay, let us come to F. In F here, there is one real number that is between the bracket, and it is being multiplied to the second complex number here, this one here, the last complex number. So what we have to do here, we'll first work out this one here in these two complex numbers. Okay, let's write it down first. 5 plus I times 2 times positive 6 times positive 6. Okay, they say here plus. So literally the way this complex number is written, so if this is the way, so you have to solve in this way. You will multiply this 2 times 6i inside there, which will give you 5 plus I. Then 2 times 6i will give you 12. It will give you 12i. You see, because there is bracket here, you will treat this one as imaginary part, and this one here is a different complex number where imaginary part is 0. We have to multiply it times positive 6. So this complex number tell us that like real part is 0 there, and that's why we just multiply this 2 outside times this, and we did not add because of the bracket. We did not add to say 2 plus 6i. No, bracket says that we are multiplying 2 times positive 6 inside. Okay, if that one is clear, so we'll multiply this one here times what all the terms, all the numbers in this complex number. See? So because 2 now separate itself away from this complex number, this one is like a complex number where real part is 0. Okay, let's multiply 12i times 5. 12 times 5 is 60, and 60i, and 12i times I will give you 12i square. 12i square. So here where there's I square, substitute -1, then you multiply times positive 12, which will later give you -12. So simply you can write this one as -12 plus 60i plus 60i. So this is how you can solve this if it is now written in the correct way. Or if it is a typing error, maybe this one to be like 5 plus I times 2 plus 6i. If this is what they mean, then it will have different way of calculating. You will just multiply the two complex numbers, this one times this one, and that is all, like how we have been multiplying this. So you will use the knowledge of these two here to work it out, so don't worry about it. So that is all for number 1. Let us come to number 2 of exercise 5 to verify or prove these complex numbers down here, and we need to prove these complex numbers. So in proving of complex numbers, so when we are proving, so we need to prove one side to be equal to the other part. Like if this one is said to be equal to this, so this you have to work this one out to give you this one. That is what they mean by verifying these complex numbers. The same to this one here. You have to work this one out to be the equal to this, and if they are equal, you will now say yeah, they are equal in your conclusion, or hence prove that they are equal. So let us start with A, number 2A. So in number 2A here we have root of 2 minus I, root of 2 minus I, minus I outside bracket 1 minus root of 2I close bracket is equal to negative 2I. So what we have to do is to prove this one here to be equal to the right hand side, side. So this is what we have to do. We have to prove this side are equal. Left hand side to be equal to the right hand side. Okay, if that is so, let's deal with this part alone. We have to deal with that part alone. Okay, here what we will first see is where are we going to start first. So the starting point is here, this one here. You have to multiply this by what is in this bracket, by that complex number. This one is negative I. Multiply negative I times the 1 here times negative root of 2I. So that is the first step you have to do here. Okay, as it is like that, we'll just write this one the same way it is, then we'll continue with that part. Root of 2 minus I minus negative I times 1 is going to give you negative I. Negative I times negative root of 2I. Negative and negative here will give you positive. It is going to be plus root of 2 I times I you'll get I square. See, that is how you are doing it. This is the way you are supposed to do it. Now, since you got I square, replace that I square with a negative 1, and this negative 1 you will multiply it times root of 2, which is positive. Since it is positive, it is going to be negative in our next step. Okay, now we'll just remove this bracket here because there's nothing that can affect the sign here outside. Okay, this is going to be root of 2 minus I, then minus that I, then minus this, because this one will affect this, so we are going to write it here as negative root of 2. Look here, root of 2 is common with the root of 2. This one is positive and this one is negative. They are going to cancel out. Root of 2 minus root of 2 is 0. But down here, down there, negative I minus I. Negative and negative here will give you something like positive here. Then you add the 2. I plus I, which is going to be 2. But we are going to maintain one negative outside. See? Here you are going to get negative 2I. This is going to be the final result on the left hand side. Now you check the right hand side. Check the right hand side here. The right hand side is negative 2I, which is here. Hence, you have now proven it. You have proof. So it is now proof. Let us go to B. B is a bit complicated, but it is very simple. We will simplify it for you. For B here, you have 1 plus 2I divided by 3 minus 4I plus 2 minus I divided by 5I. So what you have to do with this number, which is 1 plus 2I, as I'm writing, you need also to write, because I will rub this one away. Divide by 3 minus 4I, then plus 2 minus I divided by 5I is equal to negative 2 out of 5. So we are proving this part here to be equal to this part, the right hand side to be equal to left hand side. So that is what they need in their final solution. So we have to make sure our last answer is going to look like this. If it is going to look like this, then it is true that this side is equal to this side. if it is going to be the same as this one. Okay, what we have to do here when you are solving the left hand side, you have to get the LCM of these two complex numbers of the denominators. So the LCM here is going to be 5i times 3 minus 4i. This is going to be your LCM. This is going to be the LCM. So since it is going to be LCM, you are going to divide this by this one here first. If you divide it by this one here, this will cancel with this, and then you remain with the 5i. You will remain with 5i. You will multiply that 5i times the numerator times the numerator. So let us write it here. 5i times 1 plus 2i. Then we come to the second fraction. Let's divide this one by this fraction. So 5i and 5i will cancel as you are dividing. Then you take this remaining part and then you multiply it times numerator. Here you are going to have plus 3. This is only just 3 minus 4i times 2 minus I. So this one all above is the numerator of that fraction. Okay, now let us simplify it. We need to simplify 5i times I, 5i. Then 5i times 2i, you will have here positive 10. Positive 10i square. Positive 10i square. Then you come to this part, this fraction. 3 times 2, it will give you 6. Then 3 times negative I, you will get negative 3i, negative 3i. Then come to negative 4 times that. Negative 4 times 2, you will get negative 8i, negative 8i. Negative 4i times negative I, you will get positive 4i square. Positive 4i square. Divide by 5i times 3. 5i times 3 is going to give you 15i. 5i times negative 4i is going to be negative 20i square. So here where there is I square, substitute negative 1, which will affect the signs of the coefficients. Substitute negative 1 there, which is going to be positive, negative 10 here. This is going to be negative 4. This is going to be positive 20. Okay, let us, I think you have to write this thing because I'm rubbing it away, and you will not see it again. So what we will do here, we will collect the like terms, the real part together and imaginary part together. This one is going to be real number, and this one here and this one here. This one are going to be real numbers. So we are going to add them. This is going to be negative 10 plus 6 minus 4 plus 5i minus 3i minus 8i. That is what we are going to have above there. Okay, let's write it down. We'll have here negative 10, negative 10 plus 6 minus 4 plus 5i minus 3i minus 8 minus 8i divided by 20. The other part before was 20 plus 15i. So since we have reached this point here, we have to work these things here out. When we say negative 10 plus 6 minus 4, it will give us negative 8. We'll get negative 8 here, negative 8. Then positive 5i minus 3i minus 8i will give us negative 6i divided by 20 plus 15i. So as we have reached this one here, in this point here, you are not saying this is your conclusion. This is not your conclusion. So what you have to do, you multiply both numerator here and denominator by the conjugate of this denominator. So we have to change the sign here, the sign of denominator, to get the conjugate. So now we'll have negative 8 minus 6i times 20 times 20 minus 15i divided by 20 minus 15i. Okay, now we have to multiply the complex numbers above, the same for denominators. We will have negative 160 plus 120 I minus 120 I plus 90 I square divided by 400 plus 225. So here you will replace I square with negative 1 there, which is going to be a real part with this part. Then now you will add them. So we have to say now negative 160 minus 90. Negative 160 minus 90, and these two parts will cancel. 120i minus 120i, it is going to be 0. So we'll have negative 160 minus 90, which is going to be negative 250. Negative 250 divided by 400 plus 225 is 625. Here we have to simplify this by dividing this one by 125 to give you 2. Then this one by 125 to give you 5. So the final answer here is going to be negative 2 divided by 5. So this is our final result on the left hand side. Now you check this one here and check what we got here. It is the same, right? So hence it is proof. It is proven. Okay, go through it again. If you have not got those steps, you go back again and look at it, how we did those steps. So let us come to C. Let us come to 2C. For 2C, we have 5 divided by 1 minus I times 2 minus I times 3 minus I is equal to a half I. So we need to solve this. So what we have to do, we need to multiply the denominators here of that complex number. These complex numbers, these three complex numbers. So we shall start multiplying these first two brackets. Okay, 5 divided by 1 times 2 is going to give you 2. 1 times negative I, you will have negative I here. Then take negative I and multiply times that bracket. Negative I times 2, you will have 2I, negative 2I. Negative I times negative I, you will have positive I square. Positive I square. Times 3 minus I. So is equal to that part which we are trying to prove. Okay, for this one here, it is going to be negative 1, which is going to subtract these 2. So 2 minus 1 here, 2 minus 1, if we are collecting like terms, it is going to be 1. Then negative I minus 2I is going to give you negative 3I. Negative 3I. Then we multiply it times this one here, times that 3 minus I, and we have our 5 there above. We have 5 here above. Is 5 divided by this. Okay, what we have to do again is multiplying these two complex numbers. So here 1 times 3 is going to be 3, and it's going to be 3, and 1 times negative I is going to be negative I. Negative 3I times 3 is negative 9I. Negative 3I times negative I is going to be positive 3I square. Positive 3I square is equal to that. Okay, here 5 divided by this I square is going to be negative 1. Negative 1 times positive 3 is going to be negative 3. Negative 3 is going to cancel this 3. 3 minus 3 is 0. You are going to remain with negative I minus 9I, which is negative 10. Negative 10I. Negative 10I. You have to simplify it. You are not done in this way. By 5, it is 1. By 5, you will get 2. Yeah. So this is going to be equal to negative 1 out of 2I. Negative 1 out of 2I. Since I is still as denominator, you have to multiply both numerator and denominator by I, such that I will cancel down here. Okay, now let us write this one here. Negative 1 out of 2I times I, then I here. So here you will have negative I times negative 1 times I is going to give you negative I divided by 2I times I. You will get 2I square. But I square represent negative 1. So this is going to be negative I divided by 2 times negative 1 is going to give you negative 2. So divide by negative 2. You see? So negative and negative will give you positive. Therefore, this is going to be a half I. A half I. So check it here. So that is the way it is proved. Hence, here we have proven it. Okay, let us go to the last problem, which is 1 minus I square is equal to negative I, negative 2I. Okay, what we have to do on this side, we need to separate the two brackets. 1 minus I times 1 minus I, then we multiply them to be equal to that part. 1 times 1 is 1. 1 times negative I is negative I. Negative I times 1 is negative I. Negative I times negative I is going to give you positive I square. So here you will have 1 minus this negative I minus I give you negative 2. It will give you negative 2I. Yeah. What about this one here? You have to replace it with negative 1. Just replace it with negative 1. Negative 1 and 1 will cancel. Then you remain with negative 2I. This is your answer. Now you check the right hand side of this is equal to this. Hence it is proven. Hence proved. So that is all, and that is how you can solve this exercise. So if you did not get anything, just repeat the video and watch again. So thank you so much for watching this video. Make sure you subscribe to our YouTube channel and share it with the other people. Thank you. God bless you. God bless South Sudan.